good evening. Today we'll just finish up all these U-subs. Very important section, the substitution rule. It's a technique that's used over and over and over, especially through calculus 2 and calculus 3. If you have any questions about the textbook problems, please let me know because they're really good. The ones in that section are actually really good. We'll do a bunch. I thought I'd start with this guy. Evaluate the indefinite interval. No, let's do a bunch of U-subs. That'd be great. So you gotta integrate this. Now do you notice this isn't the fraction we can split up? Remember the one last class we split it up? Bill Raj, you came up with that idea. We split it up into two fractions. But this has a binomial on the bottom, so we can't do that, right?
Mm-hmm.
So our next idea would be let's approach this by at least trying the substitution rule, or U-sub. And they go, well, what would I let U equal to? Well, now you got powers in there, right? Exponents. I got an x squared and a 1 and an x to the first. Focus on the one that has the power higher by 1. So what do you think I should let U equal to?
1 over x squared.
Good. And not only the x squared, I'll let U equal the entire denominator. I'll let U equal the entire 1 plus x squared. So we'll go off to the side and we're like, let U equal 1 plus x squared. And this is going to get us through this problem. Alright, du. What's the derivative?
2x dx.
2x dx. And you'll just over and over do this 3-step technique. Sometimes you can finish in 2 though, but not here. I'm gonna have to divide just the constant, right? So 1/2 du is equivalent to the x dx then. We'll just substitute. Okay, you're coming in. You're due. Down here, you're coming in. To replace the dx and the x. Okay, here, 1/2, I'll sneak it in right there. 1/2 du. That's what's going on. Well, let me write this neater. I can put the half out here, right?
Mm-hmm.
There's a u in the denominator, there's a 1 up top, and then there's a du. There's a integral 1/2 integral 1 over u du. What's the integral 1 over u though?
Natural log absolute value of u.
That's it. So these things are on, uh-oh, there's a glare going on here. I'll have to pull that down. That's some of it down after a while. But this 1 over x become a natural log of x. U plus c, because there's no numbers, it's an indefinite integral. And don't forget we gotta resubstitute, right? What do I put back for u?
1 plus.
You got it. Hello? You leave it like that. Now, you know who Bob is? Bob's backup book. B-O-B for backup book, right?
Mm-hmm.
So you check Bob. Bob has this. Someone in the class is going to tell us why. This backup book. What the heck was that? A typo? No, it's not a typo. We got that, right? I've been telling you all along we got to put these absolute value bars here.
Mm-hmm.
That's the rule in this backup book.
Because x squared is greater than 0 all the
You
time.
got it. Outstanding, both of you. They're saying, well, x squared is always what?
Greater than
No
0.
matter what. No matter what x is, and this expression right here is going to be positive anyway, so you don't have to keep those bars there anywhere. And you can just solve it. Cool. So I just want to point that out. When you see that, I didn't want you to be thrown off. And why didn't they put bars here? If it was x cubed, they couldn't do it. right? Because you can get negatives. But x squareds, x to the fourths, x to the sixths, always positive. Don't put the bar. All right, so look at that. Now let me put the original down. This was 1 over, no, what was on top? X?
X over 1 plus x squared.
So the whole question, you kind of lead this course, or it might even happen right now. You go, man, when do I do U-subs? Well, it's like when in doubt, try a U-sub. It really is. Do a substitution rule. See if you can integrate something. But if it's quite complicated or it's a composite function, try a U-sub because it's the only technique we've learned, right? I mean, if it's just sine of x, we're just going to do the integral of sine of x. But then, sometimes these problems look alike. So that's why we don't just spend a day on U-subs. We spend 2 class days on U-subs. You know? It gets a lot of time, a lot of focus. All right. That looks just like this. Doesn't require the substitution rule though. And you go, how do I do it? And we go back, we go, oh yeah, remember? What was the derivative of arc tan of x? What was the derivative of inverse tan of x? 1 over 1 plus x squared. Very important to know this one. You go, oh, so I gotta really know that. I know. Very important we know that one. So sure enough, what is this?
1 over tan inverse x.
That's it. Done. Unless you want to write arctan. Here, arctan. You can write like that. Do you see what I mean? And it's through experience, it's through studying, it's through practicing, you recognize this. You go, oh yeah, that's just arctan. I know, here's another one. 4 over 1 plus x. When you agree this is another arctan, that's just a 4. You could take that 4 and put it out in front of here. We've been doing that all along. It's like that's 4 times the integral of 1 over 1 plus. Again, arctan, it's just 4 arctan. So, you know, not to scare you, but if you want to put parentheses on it, you can. Arctan of x. Or inverse tangent of x or arctan x. Cool. But that's the idea. You know, sometimes problems look alike. Plus, if you tried substitution rule, it wouldn't work. It wouldn't work. Remember that integral of 80x squared? So at the end of class, remind me, we gotta do that. Because the substitution rule doesn't work on that one. So when I couldn't assign this one to you, because there's no like x in front to make this work by a substitution rule. But if you're curious, in the class, we can talk about like future approaches, other techniques you'll learn where you can play around with that.
Last night you were saying that we're going to do some like two functions in the denominator.
That's right. That's exactly right. You're gonna like that one though, I know, when we do that one. Because that'll be something for Calc 2. He's gotta go to Calc 2. Oh good, center class, we'll talk about that. Like, you got a way we can approach just the integral of e to the x squared because the substitution rule doesn't work. The u-sub doesn't work. And we'll talk about what you do in the Calc 2 class. Alright. X over 1 plus x squared, 1 over 1 plus squared. So now I'm going to the textbook. This is number 45. Can I erase this? Alright. Can I erase that one? Alright. I want to hear your thoughts on this guy. I noticed the author put this problem in red bold-page print. What's that mean? It's a tough one? Let's see. Just be determined. We'll get the answer. We'll figure it out. How is this from? Well, gee, 1 plus x. I'm sorry, that's not arctan. So it looks like we try u-sub, right? But right off the bat, it doesn't work. I mean, I'm looking at it, look. It's okay in math to try something first and it doesn't work. It's kind of fun. You're like, oh, let me see. Can I try it? Let me see. U equals maybe 1 plus x squared. Yeah, but it doesn't fly. You go, why not? Because here I'm only going to what?
2x dx.
it's just not gonna work. You know why? Because I go down here, I mean, even here, 1/2 du. I mean, I cannot, this is not gonna work out for me, because this goofy 1 plus in front's in my way. This is not working. Dang on it. I was close though. Any suggestions? You got an idea?
Could you do the denominator?
Like what?
Like u equals 1 over 1 plus x2, x squared?
Well, I tried that. It was close. See, it was close, but this part's bugging me. It's in the way.
Divide by 1 plus x numerator denominator. Divide by 1 plus x on both the sides.
Can you split it? Split it.
Oh my gosh, you nailed it. Did you hear this? Jess, great idea. Cal, great idea. You know what they said? Split it. We're gonna split this fraction. We're gonna look at this we're gonna write this as, good eye that you saw that. Do that. Plus, what's the next fraction?
X over 1 plus x squared.
Here, I'll put dx's on both these. If you don't want to put two different integral symbols, you don't have to. I thought I'd emphasize. Which one's the arctan?
The left one.
Alright, so that's arctan right here. Man, great idea. That's how we attack it. You're like, oh, split it. And then which one's the u-sub? This one's the, now the u-sub will work. Let me just get this over here. This part, near over, will work now. Now it works. Yeah, split it. That becomes arctan. And then this becomes, here we go, let's do the u-sub. Put the half here. X dx is out. Put the du. And then the 1 plus x squared gets replaced with the what?
1 over u.
Oh, that looks sloppy. Then when we split up the fraction. So what do I have here? Let me write this again. 1 over u du. And we get inverse tan plus 1/2 natural log. Put your u back, right? Tell me okay, I put the u back in?
Mm-hmm.
Now I just did 2 steps at once. I want to make sure I was okay with that. It's 1/2 natural log of u, and then I resubstituted, did my resubstitution. Is that okay with that? You only have to put 1 plus constant. Do I need the bars? No, good, yeah, because it's already positive, so I can what? Does anybody want to move this here and then make it a square root? Because of log properties, you don't have to. You know what I'm talking about, log properties? Remember you could move this? Just remember that in our 141 class, you're like, yeah, you can move that here. But you don't have to. You can make that a square root of if you wanted to. Jessica, you know what?
Yeah, where did the c for the, at the bottom, at the top, when it was tan minus 1 plus c? Is it just 1 plus c because it would be constant?
You bet. You can put 2 plus c's if you wanted to.
It wouldn't matter.
It'd be, yep, and here's why. They're unknown constants.
Yeah.
They're unknown. They can be any constant available. You could even write it as, hey, a plus constant sub 1 and a plus constant sub 2, or a plus a c plus a d. You could write it that way. But we're saying, well, they're unknown, so we'll just make it what? Plus some constant c. Right? Or if you don't even like the variable c, you could use any variable. Make it a Greek variable. Do like alpha or something. Beta. We use c all the time. Everyone okay with that? Alright. Hey, try this one. Let's do an indefinite integral, and then afterwards, let's make it a definite integral. Actually, I'm gonna make that 3. Alright, this is definitely a u-sub. But I'm not just gonna let u equal to negative 3x. I'm gonna let u equal the entire what?
10 minus
The
3.
entire denominator. And you probably can see what's gonna come out of it. It's gonna be a natural log, isn't it? Does anyone see that? Good. You can get a natural log out of this, but let me just go through the motions. I think eventually a lot of you will get to the point where you do all this in your head. That's impressive too. You're kind of like, you see the derivative, you know where it falls, and you can zoom into that. The derivative is -3. Right. Step 1, step 2, constant came up. So I'm going to divide it. -1/3 du equals dx. All right, go substitute. What's this become? U. What's this replacing?
1 dx.
The 1 dx goes out. You get -1/3 u. -1/3 du. So you got a 1 times a -1/3 du. Well, that's looking all messy. Where can I put the -1/3? Out there, and I can just put the d right there. That looks way better. But do you notice it wasn't positive, it was negative, because the derivative of that 10 minus 3x, does everyone see that? It's not positive 3, it's negative 3. Sometimes on a test, students' eyes, they miss the negative. You know, they go, derivative of 10 minus 3x is 3. But there's a minus with it. So this is going to be a -1/3 natural log of
10 minus 3x plus c.
u. And then, all right, very good, I'm going to go resubstitute. I have to keep the bars though. 10 minus 3x. And we got it. Any question on that one? I used this problem last semester. This one, some people didn't get, so I want to try it with you. All right. Okay, ready? I used this one last semester. This is back in the spring. The most students got it, but it was one of those, I go, wow, a lot of people's missing. It came close, e to the 1 over x cubed. X to the 4th. Evaluate the indefinite. Okay. Is this a U-sub? Well, let's give it a shot. But you know, it's like, don't worry if we try something that doesn't work. There's nothing wrong with that. I mean, maybe I should let u equal to x to the 4th.
Yep.
Because the derivative of x to the 4th becomes 4x cubed, right? But that's not going to give us anywhere, is it?
No, let's do 1x cubed.
X to the negative.
There you go, you're onto it. So you might think, well, hey, I'll let u equal x 4, and you go, that's not going to go anywhere though. You'll get your 4x cubed, but I'm trying to get that thing out. So you're telling me, no, let it be the exponent, which was the what?
1 over x cubed.
And write it the way I heard it. What's another way to say that?
Negative
So I'm going to write it that way. I'm going to say let u equal x to a -3.
3.
That's what it's saying. Get this over with. It's saying let u be, there's your 1 over x cubed. Right in that x to -3? So when you differentiate that, it's very good. Now it's derivative, so ready? -3 in front, decrease it by 1. -3 on a number line, decrease by 1.
1.
-4.
4, yep.
But I'm with you, Cal, because we're doing antiderivatives, and we're jumping off to the side, and we're doing differentiation. You bet it can get confusing. You're like, which way am I going? That's how we do these errors. Like, so over here we're going derivative, and you're telling me that, right? Isn't that the derivative? Because we're not integrating over here, we're taking derivative. Differentiating this, -3 in front, decrease by 1, -3 goes down to a -4. dx. So step one, step two, now, step three, I got that constant. I went du over what?
3.
-3
Negative.
equals. Now, you okay if I write it this way? X to a -4. What's another way to write that? 1 over x to the 4th dx. So take this and substitute for that 1 over x to the 4th dx. Put your u up there, you're gonna have it. Kind of weird though, huh? But it was because of the negative exponent. And we didn't see that, it wasn't obvious. So did you come up with that? It was a great idea. Oh, who was it? Coming with a negative exponent, that's the idea. We're not thinking that way with this one. It was hard to see how this thing would work out. We're like, well, that's x to a -4th, I mean, that's x to the 4th, but think of this as x to the -3rd power. Differentiate, it's gonna knock the x to the 4th out. We're gonna get all u now, here we go. Come on in. Bye. PU over -1/3 of that. What replaces this? Just a,
U.
so let me write this again. You got a -1/3 e to a u. I mean, couldn't have been easier. Either go e to u is e to u, right? Got it. Now, resubstitute, what would that be?
Negative 1/3 e to the power x.
What was it?
minus
Whatever
3.
what? Whatever x cubed?
Mhm.
X to -3? Hey, after we do about 5 of these, I always like to stop and go back and do a definite integral. So when you all have that copy, I'm gonna pick two numbers. Obviously, I can't use 0 because what would happen here? 1 over what? So I can't use 0 up there. I can't use 0 up there. What would happen? Improper integral. So I'll just use 1 and 2. Alright, so here's the problem. Would you try this? Just like every 5 problems or so, I like to stop and go, alright, do a definite integral. Oh, you're the best. That's e to the 1 over x cubed. Let me make sure I copied everything right there, Justine. E to the 1 over x cubed over x to the 4th dx. Now when I change these to u's, these are now not x's anymore. What are these?
U.
U's. Now if you want, you can wait all the way to the end. You don't need the plus c, right? And right here, you can put what two numbers?
2 and 1.
2 and 1. Right? If you want to change these, go ahead, but you're going to have to use this.
So that will be 1 and 1/8, right?
There you go. And feel free to do that. You're going to find that way easier.
That's easier.
See, he does. He finds that way easier. Anybody proves that. If you're like, I'll wait till the end, all right, let's see what I get. -1/3 e to the 1 over, everyone, what's 2 cubed? 8. Subtraction, it's always subtraction. -1/3 e to the 1 over 1, which is what?
E to the 1.
E. There you go, but I'd make that minus a what?
Common and e to the power 1/8 plus e.
Is that okay with that?
Yeah.
Yeah? I know a lot of your copies. Is that okay I make that a plus?
Mhm.
Yeah? Does anybody like the factor?
1/3.
Alright.
You have to take the negative. Okay, we want to do e minus. Okay, e minus
Oh,
e to the power 1/8.
there you go. That's probably how it looks on like TI Inspire. TI Inspire does these, they'll find these antiderivatives, indefinite intervals. We get to do definite intervals. So we'll just put it in, that's exact form. That's the exact area. I mean, this stuff deals with area, doesn't it? Area? Good diet there. we're gonna see something now, you go, I've got U subs. Nothing can be stopped me, it's like, we got another one for you. Something we haven't seen before. So I hope it doesn't scare you, but I hope you kind of find it, fun. I mean, we've pretty much seen everything. Natural logs, e's, we've done all the trig functions. We dealt with arctan, and we didn't need it. You split up the fraction just in that one, that was great, that was tough. So we've kind of seen everything. Well, this is number 67 out of the book. I'm gonna make it an indefinite interval. All right, even though the book made it definite. But it's number 67, everyone, it's in 5.5, it's on page 414. But I'm telling you, we haven't seen something like this before, this is gonna look bizarre. I think I did a problem yesterday, I had like x to the fourth, but then I had an x cubed. Or I had an integral and I had x, e to the x squared, right? A lot of times the power difference was the difference by how much? 1, right? Did you notice that? That's the idea. When you do the u sub, you do the derivative knocks that power down by 1, right? And that's what makes these things work. But look at this problem. Before I do it. You got bear one before I put the next one. I want to roll that. And what did we let u equal to? X squared. And we were able to knock that x out. That was the idea. We got all changed and used it worked fine. Well, we haven't seen anything like this. But we'll make it work. Because look at the powers. Aren't they the same?
Mm-hmm.
So it's like, you might not even think substitution rule because of this. Wait a minute,
No.
that's x to the first.
Half.
And that's x to the what?
Come on.
First. Right? Usually it's x squared, and then we take the derivative, we get u equal, like, usually this is x squared minus 1. We let u equal x squared minus 1, and the derivative of x squared minus 1 is 2x, right? And then what happened? And then we're able to knock that x out. So this is a bizarre scenario, isn't it? Okay, a problem that would have been a lot easier than this, maybe, because we haven't seen this before, would have been this. And when you would have knocked this out in no time. In fact, I think we'll do this afterwards. I'll let you compare to say which one you think is easier. This one, you would fly to, because you'd let u equal x squared minus 1, the derivative is what, 2x?
Mm-hmm.
We get this x to what? Go away, who cares, we get a fraction, it's a constant front, right? This is kind of bizarre to us, we haven't seen this yet, because we're saying this is weird how this is x to the first and this is what? X to the first. Well, let's try something. Let's see if we can get to work. Let's try a u sub. Maybe we can make it work. Because we got no other option right now. And it's in this section, so somehow it's got to have to work. Any suggestions on what to let u equal to?
X minus 1.
I'm going to try it. Okay. U equals x minus 1. All right. Well, it looks like I'm only doing 2 steps, everyone. There's not going to be a third step, because what's the derivative?
Dx.
There's a 1 here, right?
Mm-hmm.
I'll put it like 1 dx, it's a dx. But this we couldn't integrate. But if we take this and we go in there, we just kind of maneuver it, we manipulate it, we're going to make it so we can make it work. Let's try it, right?
Mm-hmm.
I know it's looking like, this doesn't look like we can do this one. We'll get it. First of all, I can change dx to what?
Du.
Okay, great. That didn't help much, did it? Okay, what can I put in place of this x minus 1?
U.
Oh, it's looking better. Yeah?
Mm-hmm.
So now you got that. But right now, I'm still like this. I'm all upset. I'm crying because it's not working. What's still left over? X. And let me put the original problem down. Someone in this class is going to come up with an idea. Because it's just not working. Don't erase anything. We're onto it. It's just, I'm getting all upset. I did everything and, ugh. See? I guess I should give up. Let's not give up. Do you have an idea for it? Do you?
Could you get rid of the square root?
Nope.
Is that,
But we can somehow change x and put it in terms of u.
We're a product, right? So change x in terms of u plus 1.
You got it. All right, very good. Did anybody else see this? Anybody else see this? Claire, you see it? It's like, I'm so upset because this goofy x is still here. It's not working, daggone it. But we're like, man, if I could just get this in terms of what letter? U, right? That's what we want. In a U sub, we're trying to get all this in terms of U. That's what this means in terms of U. This daggone thing's still sitting here, right? But we went over here and you go, hold up. Can we rewrite this thing right here? I'll just draw an arrow. What would x be equal to in that expression? If u equals x minus 1, then what's x equal to? That means x equals, you bet. We let u equal x minus. Look at that fraud. So now what can I put in terms of x? It's the only time we ever did this. We went back to this, solved for x to see what we couldn't put in place of that. So what can I put in place of this guy?
U plus 1.
And now we're going to go to the problem. I'm going to put a parentheses around that. And I'm going to put a parentheses around it because there's a square root of u next to it. Let me rewrite this. Oh, this is half face now. We got it now. That's the idea. But you go, how many of those? And that's why that was buried at the end of the textbook. He had this buried way near the end one like this. Because you don't get these too often. How many of these do I get in my Calc 2 and Calc 3 courses? Practically none of these. I don't see these often. Seriously.
No, but if you
I have a
do
problem.
integration by product, then you can do it, right?
You could try it.
Okay.
You could try it, but that square root throws it off,
Yeah.
I think. Hey, but that's what's neat. Sometimes you can do it with two techniques. Any suggestions how to do this?
You can add the exponents.
Brilliant. That one he's basically saying like distributive property. To get through this mess. It's looking weird. You go, what do I gotta do another U sub now? He's just saying distribute this. Because he's saying here, write this U times square root U plus square root U. He says distribute this. That's what when he said add exponents. And when that's U to a what? 1/2? That's U to what power? 1. So hey, we gotta review. Sometimes these are confusing. Go back to the old algebra days. How did you simplify that back in the day?
Add them.
You added them, right? Remember? Stuff like that, you added powers. So that's u to a 1, that's u to a 1/2. What's 1 plus a 1/2? 1 1/2. What's that as
3
a?
and 3 half.
There you go. There you go. We're just going to integrate both of these. Right? Yeah, let me just swing this over here because we're running out of room. Let me just keep a wall here so this is kind of outside of this. Let me rewrite it. You got u to the 3/2 plus u to the 1/2. And here we go, Arsma. Here we go again with the u to the 5/2. I pumped it up by 1 because I'm doing the antiderivative. And then I divide by 5/2. Go ahead, Josephine.
Where'd you get the u to the 3 halves?
With this, before I do it, I just want to make sure you're comfortable. Like, we got to go back, old school math, algebra, x squared, x cubed. What do you do with these? You do it. So you go this, when you have something like this, in this scenario, you add the powers. So when you and I, once he thought to distribute this, he's talking about take this exponent and add to that exponent. That one has, Josephine, a 1. This one has a 1/2, and 1 plus a 1/2, 3/2. That's where it's coming from. And so ours, when I'll do this again, u to the 5/2 over 5/2, which means I can flip this and do what? Some of you, a lot of you automatically do that, don't you? You're just like 2/5, u to the 5/2. Pump up a 1/2 by 1, that's 3/2. Now, this time I won't do it. Could you tell me what happens when you divide 3/2? Multiply what?
2/3.
I'll see. 2/5 u to the 5/2 plus 2/3 u to 3/2 plus c. And what was u again?
X minus 1.
Okay, so this is going to look weird. But this is the answer. Ready? 2/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3. It does look weird though, huh?
So now,
You don't get many of those though.
so number 69, should we take like natural log of x as what you say?
Let's do it.
U?
Good eye, I like that one.
Yeah.
Oh, and he dove into the textbook. If you got your textbook available, let's do some of these. This is a good one. It's got an L and X in there. Now what's the derivative of x?
1 over x.
1 over x, right? Can I raise?
Mhm.
Everyone try this. Alright, I like that one too.
Yeah.
That's a good one. First of all, I want to show you something, everyone. When they write it like this, Josephine, this is how it's presented in this problem. This is number 69. You see this? They put that there? Absolutely. If you prefer to look at that problem as 1 over x, square root natural log x, and put the dx where? There?
Mhm.
Definitely do it, if you prefer that. I can't tell you how many times teaching calculus over the years, that's what threw the student off. They go, oh, if I knew that, I could have got the problem on the test. Just that simple concept. This was bugging them, how this was up here, and they were used to it over here. Threw them off. Threw them off their game. They're used to that, and that kind of thing, like, I left that one blank. The dx up there was bugging me. And I said, oh, just do this. And they go, oh, you're kidding me. Now we got it. So keep in mind, you can always do that. All right, you made the suggestion. What are you letting you equal?
Natural log of x.
All right. Step 1. Step 2. du
1 over
equals
1 over x dx.
1 over x dx. I'm not doing a step 3 this time, am I?
Nope.
No constants. No step 3. I'm going in right now. We're going to get it. Go ahead. Oh, you sure? Hey, but look, there were no constants now, so I'm like, stop here. All right, you're replacing the 1 over x and the dx. Just du. And what replaces the element of x? But I want a radical stays. How do you integrate a 1 over square root of u?
It is over half.
Now I've seen this on tests. Can you find my error?
Minus minus.
Minus negative, u to the negative 1/2, right? To get it up, right?
Mhm.
Right now, it's like, wait, that's u to a negative 1/2. Now pump up negative 1/2 by 1. I love integrating this, everyone. Because if you pump up negative 1/2 by 1, it becomes a half.
Plus 1.
And then when you divide by a half,
It becomes 2.
it looks all sloppy. We're saying just multiply by what?
By 2.
The reciprocal too. 2 u to the 1/2. That's a nice one. I like that. Because you can put the radical back. Look, a u is a 1/2. I want to something with the square root. Right? Here, let me put my plus c in here. Plus c. 2
Natural log of
square root of.
x plus c.
Now look, I'm not putting bars on that. Students ask me that over the years in calculus. Wait, why didn't you put the bars this time? I didn't do this.
1
did I?
over x. Yeah.
Look, I didn't do this. I just let u equal natural log of x. The original u didn't have a bar on the x. This one did. No bars. So yes, that domain would be limited. That would have a limited domain because natural log has a limited domain for that problem.
That's from 0 to infinity, right?
And open parenthesis on to 0.
0, yep.
You can't include 0. So what we're saying, when I couldn't ask you on this problem to do this, that would make it undefined. Improper integral. Do that in calc 2. And you'll like, do that in calc 2. I couldn't even do this. Does anybody know why? What's natural log of 1?
0,
See, 0 and a bar. I couldn't. I have to start this thing where
2.
at least like 2 or something. Then you do 2 square root ln of 5 minus 2 square root ln of 2, right?
Mhm.
Every once in a while, it's good to go back and talk about definite intervals. All right. Hey, scan over page 414. I'm gonna look for anything that threw people off over the years. Oh, I think it's always good just to insert one of these. Ready? I love doing this stuff. You just get better and better and better. Because the whole idea is, you're doing all these problems on the final exam next week. all you're gonna see are integrals. And you're like, when do I use U-subs? When in doubt, try it. Right? When in doubt, try it. Well, perhaps you try U-sub here. But Belraj, we don't need a U-sub, do we?
Nope.
So we just did U-sub after U-sub after U-sub after U-sub. We're thinking, oh, we just do it every time, but now we're back to this. This is just a little monomial in the denominator. Can't we split this?
Mm-hmm.
We don't need a U-sub. You could try a U-sub, you'd go nowhere. You might think, oh, I'll knock that out. You're not gonna get this out of the way. So split it. Right? Split that thing.
2x to the power minus 2. Oh, sorry. No problem, sir.
So what's a good way to
No, no,
write that?
square, x squared, 2 over x
Oh,
squared.
thank you so much.
You forgot an S.
Right up here, he's like, hey, thank you so much. 2x over x cubed plus x squared over x cubed. Alright? That's 2x to the negative 2?
Mm-hmm.
Is that okay there? Alright. Plus, I mean, I can write it as x to negative 1, but I think I prefer to write it like this so I know about integrals of 1 over x's. Which one's the element of x?
The right one.
Hey Jess, I'm just gonna put 1 plus c again.
Wait, what are you doing with it?
Were you okay that this became integral 1 over x? That's log x. I haven't integrated this yet though. Do you see how that became this? Okay, I'll take it slow. I'm gonna do one more step. That would be 2 over x squared, wouldn't it? Do you see that, Josephine? From there to there? Right, an x over x cubed. It's almost like x cubed means 3x's multiplied.
That's just an exponent rule, right? Like if you have an x squared over an x.
Yep. You can do it 2 ways. Do it the way you prefer. Sometimes it's not hard at all just to expand. When you have something like that, I want you to think, well, that's an x over 3x's multiplied. Doesn't something cancel? Sometimes it's fun just to think, well, expansion, that's x over 3x. What would cancel there, Josephine? One of the x's, right? But there's another way to do it. If you did that subtraction rule, that would be x to the 1 minus 3, which makes it x and negative 2. So isn't that funny how much this stuff comes into play in these problems? That's when you add. This is when you do what?
Subtract.
Add powers, subtract powers. I don't know if we've seen this yet, but I bet you all know what to do there.
Multiply.
That's when you multiply. You know, just those old rules. Hey, I've pumped that up by 1. Kel, we gotta be careful now. Like
Negative.
derivative or antiderivative? Alright, antiderivative. Add 1. So on the number line, negative 2 plus 1 makes it
Negative 1.
negative 1. Okay. Sometimes you gotta stop and you gotta hesitate. Because U-subs involve derivatives, and now we're doing antiderivative. Gets confusing. I think we got it. Pump it up by negative 1 and then divide by negative 1.
So it becomes negative 2.
Hey, Josephine, are you okay with this one? I'm just gonna leave it negative 2, because that's negative, but then I'll bring that back downstairs. Because x and negative 1 means 1 over x. That's how I'm gonna write it. Negative 2 over x. That guy. Alright, good.
Wait, what?
Oh, did you see that? Want me to do it again?
Yeah.
Alright, so something's going on here. Whoop. Back it up. Back it up. X to a negative 1 means, I'll add to this list. Means 1 over what? X to the first. So negative exponents, this stuff, it's funny, this stuff comes important here. That means 1 over x. So I can take, let me hide all that there, Sterling. X and negative 1 means 1 over x. Alright, I'll write 1 over x. But then there's a negative what number?
Okay.
A negative 2. So I'll just write it as negative 2 times 1 over x, which I can write like that.
Okay.
Negative 2 times 1 over x, negative 2 over x.
Can you write it like natural log x to the power x minus 2 divided by x?
Yeah. And did you want to get common denominators? You could. This is fine. But if you got common denominators, you'd have to multiply x over x here.
Yeah,
And
then
you get x natural log of x minus 2 all over x. Let me
Then-
put that. It's not a bad idea.
yeah,
I like it, or you write it like that. This is fine now.
x we can also take it as a power too, right?
Right, one common denominator.
But can I take the x as a power?
Oh, he goes, I'm gonna do this.
Yeah.
Yeah, I like it. Take it there. That worked. Doing a great job. I'll look for another goofy one. Okay. I think you'll get it though. I use this one in the spring. Most students got it. Did you try it? Now everyone, I could have written it like that, but on my test I decided to write it like this. So I'm going to present it to you in the same way. Try that one. Try to start to finish on it.
Okay.
Use subs. I'll look for another weird one. Give me another goofy one. Oh yeah. Now, when you can do these all in your head, that's pretty darn good. That's pretty darn good. Jess, what would you let u equal to?
I think I did it wrong. And when I said equal to sine x, it didn't work.
And you just let u equal sine x? That's it?
Would you have to do sine x squared?
Never. I want to point that out. Have you ever noticed with these u subs, I've never done,
First
and note, I want something to kind of key in on. I've never done like u equals square root of something. I've never done u like equal to something squared. It's always been what? Like u equal to secant of x, u equal to sine of x, u equal to x squared plus 1. So you were right. You got it. Now let me keep going here. du equals,
Negative 15.
and it's positive, right?
Positive, yeah.
Because we're off to the side, derivative of s is c. So cosine x dx. No step 3, right? Step 1, step 2. Off to the side. Jess, you got it. Let's go in. It's going to work. So look at this. Jess, what is going to replace the cos x dx? All this. You put a line to it. And you're just going to put a du. And what's going to replace the sine of x? No, well, the squared stay. Who cares about a squared stay? That's fine. We just can't have any x's stay. Or if this was in terms of theta, we can't have it. We need everything in terms of u. Oh, you got it. 1 over u squared du. But Jess, this is what I saw. I gave this test to everyone in early May. Remember we lost a couple days with the snow and ice?
Mm-hmm.
You remember that? I gave this in early May, and a lot of students, yeah, they did okay with this. And then I saw this. Just a few students. Is that right?
Nah.
There's something about 1 over u squared that looks like this. And it's not, right? That's you only do this for 1 over u. So how do you treat these?
Minus 2.
Bring it up top, u to the,
Minus 2.
it is Sterling, it's this idea. You know, we're gonna get it like this. So we say, all right, that's the integral of u to the -2. Pump it up by 1. Just be careful on the number line. -2 plus 1, you're like, is that -3 or -1?
Negative.
-1. Plus c. So this will, hey Sterling, this will be similar to that other one.
Yeah.
I'll bring that below, I'll keep it negative. I'll bring that below and just keep it negative. It'll be -1 over u. And u is
Sin x.
sin x. Now remember I talked about Bob? Who's Bob?
Back of book,
Why did back a book write like this?
because negative cosecant.
Let me see it. Yeah, there you go. Back of the book did that. Don't let it freak you out. You're okay. This is fine, right? You can do this if you want. All those trig identities, feel free to do that stuff. You get the power to use any trig identity. There's been times where I'm marking a test, and I'm about to put a X on something, and I go, whoa, wait. And I start looking at it, oh my gosh, dude put a trig identity in there and got it all worked out and stuff, you know? Dude did it right. I think I'll show it to you, look. We did this last class, but last time we let u equal sin of x. Can we look at this 2 different ways? This is fun. Okay. U sub, which I let u equal to.
Cosine x.
See, last class we let u equal sin x.
Mhm.
It worked. Let u equal cosine x. No, the problem you did, Jess, if we let u equal to cosine, it wouldn't have worked. So you had to put it, what the key is, think about what's in the parentheses, or what's in the exponent, or what's under a radical. It's usually what you're letting u equal to. The derivative is, or be careful, positive or negative?
Negative sin x.
Negative sine of x. So I will do a step 3, because there's a negative. Step 1, step 2, step 3, negative du is equal to sine of x dx. Cool? Right.
Could you explain why you did the third step in this again?
Oh, I do third step. I do it most of the time. It's when a constant pops up over here. You know, other than just positive 1. I should be clear when I say that because 1 is a constant. There's always a coefficient of 1 of these. When it's anything other than just positive 1. So if you get right here, for I, you get a 3, a 2, a 4, a 5, then take it and divide it on both sides of the equation. But this wasn't a positive 1, it was a negative 1. So I was like, all right, let me put it over here. Because look, this thing didn't have a negative in it, did it? So I'm thinking, this is what I'm trying to replace. That's how we gotta think. I'm trying to replace that, this didn't have a negative in it. Box that, go knock the sin x dx out. Box this, go knock out the cos. Let's see what we get. By negative q
du.
du. See? U is cos. Negative u is the sin x dx. Feel free, if you gotta use colored pencils, use them to just knock things out. Now, what's the integral of a negative u? So what do you get?
So negative cosine square x divided by 2 plus c.
Okay. Well, now this is what we did yesterday. Sine of x. Cosine x. Stop there. For odd, look, no constant. I mean, it's a 1, but nothing other than a 1, right?
Mhm.
No negatives, no 2s. I'm going to stop there. I could go in now on this one. This gets replaced with
U.
u. This part gets replaced with the
du.
no negatives. I get just u squared over 2. So my answer now is sine squared x. So yeah, everyone, there are different antiderivatives possible. This is an answer or this. You go, how? Because of the plus c. That's why. But I want to make sure you understand why we can do this. Go ahead, Josephine.
Why is it negative cosine squared?
It was negative because that negative came up there.
No, but why is it cosine squared?
Oh, when we did the u squared over 2, we had to go back and replace that u. And then in this one over here, Josephine, this one we let u equal sine of x. So I had to put the u here as sine of x, Jess.
For the test, would you ask us to show like more than one anti-linear, or do we just have to know one?
No.
Okay.
But hey, you know what's neat? You just asked that. You know those AP exams? Well, you know, students get like 3, 4s, and 5s, all that stuff. They always put a killer problem there at the end. First, they make them really long. They go, here, you got 10 minutes to do this, right? You know, like 20 minutes. Who in here is taking the math AP exams? Aren't you crunched for time? I mean, you're flying and you're still like, oh, come on now. And they had one buried at like number 90. Just like that, all right? And it was this problem. That's why I'm doing it now. And they go, it was multiple choice. And they go, which one of these is possible? And then D was the what? All of the above. Alright, now one of the choices was y squared x over 2 plus c. It said which one of the following antiderivatives? Another one was negative cosine squared over 2 plus c. I'm not going to put the third choice up yet. But already, logically, what should be the answer to that problem?
A and B.
Whoever got to this, Jess, whoever got to this point, what would be the answer? It's got to be all of the above, right? Because we already know that these two what? Work that way. But it was the question, like, who got that far? Who got to number 90 to try that problem? So I want to show you the third way. You ready? Like, there's a third way to do this?
Okay.
And you go, what other way is it? Haven't we done both cases? So you go, all right, that's the beauty of mathematics. Who knows a trig identity? It's a
Two sines.
double angle identity.
Sine 2a.
It looks like this, but it has a 2 in front.
2 sine a cos a.
So I'm going to go over here. And
Okay.
that's why knowing those trig identities are so important. There's a trig identity that says this. It's a double angle identity. Does that what say that?
Mm-hmm.
So if, this would be a third way. So Jess, you'll like this. Let me just put, this would be way through. What was the original problem? Integral of sine of x, cosine of x, right? This would be a third way. Alright.
So sine
Can
2a.
I erase this?
Yeah.
Sterling, okay if I erase all these?
Yeah.
That one okay? I'm gonna erase this stuff. The
So-
old school algebra, right?
Oh, so
Back
sine
in the day.
sine 2x divided by 2.
You got it. So look at this trig identity. Can I solve for sine x, cosine x over here?
Uh-huh.
Just divide the what?
By 2.
So look. This would be a third way to this problem. So Jack, to answer your question? No, I wouldn't do that. But they buried it at number 90 and they go, this was the question. So I can rewrite this as, what can I substitute in there? I can write it
Sine
as
2x.
1/2 of a sine 2x. But it still requires a u sub, so let's do it. This is good practice, Owen. If I do a u sub here, I gotta let u equal to what?
2x.
2x. What's d do?
X. 2, sorry.
2dx?
Mm-hmm.
Step 3, I got a constant, I have to divide it. Step 1, step 2, step 3,
1
1/2 du equals
dx.
dx. And there's already a half there, so what's a half times a half?
1/4.
Now be careful. That's 1/4. Integral sign, is it positive cos or negative cos?
Negative.
Yep, negative cos. So this was the other option. And then Jess, I'm gonna put the u back. Negative 1/4 cosine of
2x.
2. That was this one. But Jess was like, who got that far, right? Now, if they knew just to try these two, I think logically they'd be like, well, if it's these already, then this one has to be. Right? Because they're already confident that 2 of them. There's 3 different ways you can write that.
That's going to take a lot of time.
I know. Yeah, and who has enough time to do that? It was buried way at the end. Not many get the number 90. When they go, you got 28 minutes to do these 30 multiple choice problems, take a break, come back, you gotta do numbers 70 to 90, and you get 28 more minutes, or 30 more minutes. You just crunch for time. Same thing with the SATs. Fine. Cool. Isn't that neat? But I guess, Jess, if I put that problem on my test, then I gotta put this on my answer key. Because students will write this 3 different ways, right? Yeah. Cool. All right. Everyone, I'm looking in the textbook and I see a good one. This is number 41. Good luck.
So that should be like 1/10.
Yeah, that's right. I'm stumped. Josephine, I am stumped here. Where do I go? Oh, maybe it's one of these. No, it isn't.
It's 1/10.
Good. But then I'm still stuck.
So,
Think of that 5-star trig identity.
10 inverse x.
Cosine over sine. Tangent, sine over cosine, right?
Uh-huh.
That's how we get the integral of tangent. Let's make this what? Cosine x over?
Sin x. What if we do like tan inverse x?
Yeah, we couldn't do it because cotangent. Inverse tan would be what?
Inverse cotangent. We have to find the derivative. 3 integration, right?
Yeah.
Okay.
This will do it though. Now, hey, I'm gonna go to Jess on this. Do you know what I should let u equal to?
sorry,
So it can only be 1. Do you know which one?
sorry.
Yep, it's the denominator. Let u be the denominator, whatever the denominator is, because it'll knock out the top. It'll knock out the top. U equals the sine of x, you got it? So always think like that. Even if we did integral of tangent here, Josephine, we would have done the sine over cosine. Let u be the denominator, which would have been the cosine of x. Okay with that? Good. So I'm gonna let this happen. Boom, positive, right?
Mm-hmm.
Go in right now. Make the changes. Substitute. You're gone, you're du. You're gone, you're a u. 1 over u du. What's the integral 1 over u?
Natural log.
Natural log of u.
Absolute value of sin x plus c.
Which is natural log of sine x. I saw these so often in calculus 1, 2, 3. I just ended up memorizing cotangent, tangent. Can you go back to your notes? What was the answer to the natural log of it was a natural log. You remember integral of cotangent?
Secant.
Yep, natural log of secant is what came out. Or negative natural log of cosine.
Uh-huh.
I just remember I was like, this comes up so often. Right? Hey, what will you see over and over and over and over and over again? Problems like this. And yes, it involves a u sub. What will you see over and over? Try it. What will you see over and over and over again? Problems like this. And yes, it involves a u sub. This is through your calc days.
But that one is like 1/6 e to the power 6x.
Yep. And so if you can do these in your head, like you just did, by all means do it. If you're like, I can do all the steps. You're telling me this is going to be 1/6 e to the 6x plus c. Just put it. That's fine.
Can you do that on the test?
Yes. I'm serious. If you look, you see this, you're like, I know what happens. I know, I get the steps. Let u equal 6x. Step 2, this 6. And then step 3, you divide the what?
1/6.
6. If you're one of these students, you're like, I see the math in my head. Integral of e to u is e to u, and then you put your u back. The ration. By all means, boom. Right? I'm like, hey, where's the u sub and stuff? I know you can do all that in your head. That was good. You might be able to do that one in your head.
There's
Right?
no X, so wouldn't that just be, where is it?
Yeah, way to go, Messenger. Thanks for catching that. She's like, where's the x? And when that was just a constant, right? So wouldn't this just be, that would have been cosine 4 pi, you just put an x next to it, right? Does everyone agree? Look, what, like what's the integral just 2? It's not 0.
X, 2x.
2x. So did you see my little typo? I didn't do it on purpose. I meant to put cosine of pi x. And I wrote cosine of what, pi 5? 4 pi? Try this one. There's the barrel.
Okay.
What would you let u equal to?
Pi x.
But see, this is another one. There's you in this class, you're like, I can do it in my head. It's awesome. You're gonna notice a fraction comes out. Du is pi dx. Farad constant came up, so I'm dividing it. 1 over pi du equals dx. Step 1, step 2, step 3, every time. Right? Boom, boom, boom. Every time you're doing a U-sub, come on in here and knock stuff out. What knocks the dx out? 1 over pi du? 1 over pi. Cos stays, but what knocks out pi of x? Now what's the over cos u?
Sine.
And it's positive, isn't it?
Mm-hmm.
So 1 over pi
Sine
sine of
pi x. Let's see.
Spell Raj, if you could do that one in your head, that's fine. Students do that in their head. Because you get tired of doing it, you're like, I know what's going to happen. The pi is going to land in the denominator. What happened with this one again?
1 6.
U-sub, U sub, right? U equals 6x. Right? Blah, 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 blah. There you go. 1/6 e to the 6x plus c. You'll probably get a Calc 2 teacher who would get mad if you made them, ask them to do this substitution rule to show them why. They'd be like, you should know that, right? They'd probably be like, you should do that mentally. But don't worry if you have to do all the steps to do even that one. It does not take long to do 3 steps. Right? U equals 6x. D equals 6. Now, Farad, do you see why this came out here, or should I show all the steps? You do? I'll do. This will come out though, watch. Here we go. U equals to what? 6x? Du equals 60x? Constant? Other than 1. 1/6 du equals dx. So let's go in, let's move in. Let's substitute. What knocks out dx? The 1/6 du. Bye-bye. 1/6 du. Leave the e, but what knocks out that 6x? The u. 1/6 du. Now what was u? There you go. Ta-da! What do y'all think? I love the repeat problems too. Here you go. What did you give them like this? We'll do it again. I didn't have the 4 there though.
Yeah.
I didn't have the 4 there. What would you let u equal to?
X square.
Du?
2x.
Farad, constant. 1/2, right?
Mm-hmm.
If it was 1, I would have left it, but it's a positive 2, so 1/2 du is x dx. But that 4 is still there.
Can you take it out?
That's not a bad idea. You said put it out here?
Yeah.
I like that. I'm going to do that. Because take that 4 out. The half du will knock out the what? That. This u will knock this out. But I like what you're saying. Take out the 4 and the what?
Half.
What's a 4 times a half?
2.
2. I should have crossed it out. The 1/2 du replaced the dx, but also the what? That x got knocked out, see? That's the idea. Now what's gonna go v to u?
To the u.
So my answer is 2e to the u. Gonna go v to u, z to u, 2e to the
X squared.
x squared plus. So I think at this point I could never stump you. I think I could dive in that book, whether it's an ln of x or a square root, I just don't think I can get you. I thought the tough ones, Jess, you got that one where you said split it up, remember? I thought the goofy one was 67 with the x and the square root of x minus 1. I should do 65 though, Erwin. I just saw 65. Sometimes this throws it off. Jess, you get all that? You sure? Did everyone get that? Copy all that? I should do 65. You know why? It had an A in it. We gotta talk about that. Like, what happens when they do that stuff? You'll see that often in your next math class. And if I didn't like show you a few of these, you might be like, what do I do there? Now, when they made a note off to the side, this is what they wrote. A has to be a number greater than 0. Does anybody know why they wrote that? Because
Imaginary number.
yeah, they just said A has to be greater than 0. But A is just a constant, right?
Mm-hmm.
We're differentiating with respect to what letter? X. So what would I let u equal to?
X squared plus
Usually
a,
it's under the radical,
plus a squared.
right? Jess, I won't let it equal to that with the radical. It's usually just the stuff under the radical or the thing in the parentheses or the thing up in the exponent. I'm just going to let u equal the x squared plus a squared. Now, can you find my error? I didn't want you doing this throughout Calc 2 and Calc 3. You know, do you find my error?
Yep,
It's
2a,
constant.
0.
It's a constant, it doesn't.
That's a constant. I'm differentiating with, here's the idea, I differentiated with respect to what letter? X. You know, that's what we gotta be careful, even myself as an instructor, I keep saying, the derivative is, well, I really should be saying, differentiating with respect to x, that's an a, so if I differentiate with respect to x, that's just 0, right? Because I'm differentiating with respect to x, not with respect to a. Now, constant. Okay, now what do we get? 5 by 1/2 and a du. Okay. Now what knocks this middle stuff out? Okay. Sterling, I gotta think u squared of u to the 1/2, right?
Mm-hmm.
U to the 1/2, pump it up by 1,
3 halves.
and then divide by, right?
Yep, 2/3.
U to 3 halves, divide 3 halves. U to the flip. Yeah? Jess, okay with that? Yeah, I'm looking at eyes, make sure everyone's okay. What's 2, anything cancel in there?
Yeah, 2.
Plus C, huh?
Mm-hmm.
Right? Let me back it up, Judge D. Square root of u, that's u to the 1/2. Pump it up by 1, then divide by that number. Pump it up by 1, right? You got it? And then what cancels over here? The 2's? Awesome. Now what's that 1/3? What's u? X squared plus a squared to the. Can I do another one of these? Josephine, because I know that 2/3 thing threw you off. Can I do another one? We all love multiple choice. Alright, give me a shot.
A.
C.
Oh, good, I'm liking this, because I'm hearing 2 different letters.
You'd be over half, right?
I'm liking this. Right?
Hold on a second, let me see. You'd be over half.
I'm liking this. And just take it slow, you know, you're on the final, you're like, wait, let me just, does that look like a U-sub? When in doubt, do what? U-sub, right? Yeah? What are you equal to?
2x plus 1.
Alright. What's the derivative?
Yeah. 2, yeah.
Yes?
D over 2.
Divide by 2.
Farad, I got a 2. I'm hearing, Sarah says divide the 2.
So A, answer is A.
Alright, let's get in there, right? Let's go substitute. What's the 1/2 du replacing?
Dx.
1/2 du. Now what's replacing that 2x plus 1?
U.
Now it looks all sloppy, so I'm gonna rewrite this, right? Put the half out here, keep the square root u, and then do a, come on. We don't wanna guess, right? We're not gonna guess this hard, we're gonna get this. Integral of square root of u, here it comes again.
Yeah.
That's u to the 1/2, so u to the 3/2 times.
Oh, C, yeah. Sorry,
That's
C.
it.
Sorry, C, yeah.
And at this point, you might already know the answer,
Mm-hmm.
right?
One
You might
target.
just go up, because you're looking to circle the right answer. They all look the daggone same. Come on, which one is it?
C, C, yeah.
C.
You follow? You see that, Justin? Oh, good. I know. Very good. Veronica getting that? Good.
Is that going to be on the final, not on the next test, right?
That's right, next test, fill in the blank. Fill in the blank, but the final, you get to play around with this. The beauty is the answer's there somewhere. What's the danger? When they all look the daggone what? Same, you're like, so you're gonna take it slow and do these steps and you'll crunch it out. Hey, so the last thing I wanted to show you today is this. This is fun. Come on, I had to show you, huh? Does the U-sub work? We just did one like this, but what did I have in front? Like an X or a 4X? Because the power difference by what? 1, right?
Mm-hmm.
But, does anybody know what this symbol means?
Summation.
That means summation. Like sum of terms. Like if I put like n here, and I said start at 1 and go to like 12, this would mean mathematically 1 plus 2 plus 3 plus 4 plus 5 plus 6, and stop where?
12.
At 12, and add all the numbers up. Alright, that's what that means. Well, believe it or not, mathematicians figured out that this function right here is equivalent to this. If you start at 0 and you go to infinity. Now, does anybody know what that symbol is right there?
Factorial.
It's a factorial. So you're like, what's a factorial? 3 factorial means 3 times 2 times 1, which is 6. Or 4 factorial is 4 times 3 times 2 times 1, which is 24. Anyways, if that's true, can't we substitute something if this is a mathematically true statement? And everyone, this is convergent for all real numbers. That's the beauty of it. It's like, does it only work for certain x values? Nope. When we do this is Calc 2. This is Calc 2, so Jess, don't get stressed like, give me this one. No. This is Calculus 2, but you'll see next term. If that's e to the x, then what can I replace this with? Think about it. What can I say? What would e to the x squared equal? Like if you knew that. So in Calc 2 you know this, then e to the x squared would have to be, just copy everything.
X to the 2 over 2 factorial.
Just change that x to what? Change x to a x squared, right? And then if you got x squared to the n, that becomes x to the 2n. Do you agree? Or erase that property. Remember this property? Art, you told me earlier on these cases, we multiply these. So if you got x squared to the n, then that beat x to the 2n.
Yep.
So what we'll do is, let's put that there, and then we'll integrate it.
Okay.
Does that sound cool? Right? Now we got a way to integrate this. Because the U sub didn't work. Your other techniques won't work. Let's put this in there. So watch this. You're like, okay. I'm telling you, you're going to love Calc 2. So now what's this? N equals what? 0?
Mm-hmm.
Infinity. X to the 2n over what? N factorial?
Mm-hmm.
Why is it not 2n factorial?
Great question. Great question. When this, I'm going to color code. Right? Court, this, that means like whatever I put here has to replace that. So, but this didn't have an x. So this, by this formula, I'm like, it's like a function. I'm like, then I'm going to replace that right there with x squared. It's the only thing that got changed. There's still an n there.
Okay.
Yep, it's like, yep, jink, jink. So this was x cubed, I would have just made that x cubed right there. Because this didn't have an x there. So it's like a function game. Like whatever this, gotta change that. Everything else stays put.
Okay.
And then here, I get this. Now when look, I still have to write what? That's what? dx, so what goes right here?
Dx.
And that dx is important. Because then when you integrate, can you help me with this? Integrate with respect to what letter?
X.
All right, let me see, because there's a lot of variables in here. Do you see n's?
Mm-hmm.
So ignore those n's. Integrate this with respect to what letter?
X.
X. So x squared, sterling, and that what, x cubed over 3?
Mm-hmm.
Cool, let me do another one. X to the 4th. That would be x to the 5th over 5?
Mm-hmm.
What about x to the 2n? X to the 2n, just add what number?
Plus 1.
Plus 1. So watch what I'm going to get. Take off this elongated s,
Uh-huh.
do the antiderivative. This stays, this stays. All that stays. Now watch this. Pump this up by 1. And then you divide by that constant, which is now what?
2n plus 1.
Then you can put your plus z. That's it. That would evaluate it. That could be
Oh.
programmed into a calculator.
Is that about a
It could run to an infinite sum. You go, well, it probably wouldn't go to infinity, but it'd go to enough places. Those programs here, so it would be accurate to like 8 places or so. So if you put like, even a definite integral here, let's say it went from 0 to 5, right?
You just put the number.
Well,
there.
x equals 0 would get thrown out, but you put a 5 here, and then it would sum all those terms.
Yep.
Probably only sum out, you'd have to sum like the first 50 terms or so. Isn't that cool?
So this is about the Taylor series, right? Or the Maclaurin?
That's right.
Taylor.
Yep. And they call it a Maclaurin series.
Maclaurin series, yeah.
That's a Maclaurin series, which is a Taylor series.
Yeah.
It's a Maclaurin series, a Taylor series centered at 0.
Gotcha.
And that's a Maclaurin series. It's convergent for all real numbers. So you don't have to like, with this, you go, wait, doesn't this only work for certain x values?
No.
Because when you get natural logs and stuff, you gotta be careful with that stuff. So isn't that cool though? You'll love calc 2. I wanted to show that to you. So if you're like, I guess there's no way to integrate that. You learn other techniques. That's the beauty of calculus. You'll learn some other but it does look scary looking, doesn't it? When you leave that on the board and then the Calc 1 students come in, they're like, oh man, I don't want to take Calc 2. Because they see this, it looks all, but it's not hard, is it? Exactly. And if you got numbers, and want this at a 5, make that a 5. Change that to 5 right there. And then some numbers, you just let some, put a bunch of numbers into a computer and let it run. You can use Microsoft Excel or a calculator. Cool? Hey, so we were going to have the test tomorrow. But like, how about this? We'll make the test what? Monday? I think Jess wanted that, right? Jess wanted it on Monday. I'm playing with that. Oh, was there someone in here who wanted to take the test tomorrow? No? All right, cool. Hey, so tomorrow we'll just review. Now if you're like, listen, if you're bored with reviewing chapter 5 stuff, then couldn't you ask me questions like from old tests? Because a week from now you're gearing towards the what? The final. You might start like, hey, can I do a problem from test, or you might be like, test 2, I don't know how to do implicit differentiation. For test 1, you might be like, can we do limits, or you might say, can we do L'Hopital's rule? And we can make stuff up.
In fact, chapter
Right?
5
And then
was-
Tuesday's a review day too, true? Hey, if you don't come tomorrow, we're just reviewing, right? It's not a big deal if I'm not gonna be like, you know, Fred was not here. Where's Fred? Oh, we're reviewing. Fred's probably studying on her own. Have a great day.
in my
Are
opinion,
you gonna take Calc 2 next